In this video, you will learn about angles of elevation and angles of depression. Now, suppose a person on the ground sees something up above in a hot air balloon at a 38-degree angle above a horizontal line. This is what we refer to as an angle of elevation, because what you're doing is from the horizontal line at that person's eyesight, they are looking up to see that hot air balloon, making it your angle of elevation. Now it says at the same time, a person in the hot air balloon is looking down at the person on the ground at 38-degree angle below the horizontal line. This is called an angle of depression. The reason being, if you were going from the horizontal line, the person in the hot air balloon would have to look down from the horizontal line, making it the angle of depression. Now it says, by examining the diagram, why is the angle of elevation always congruent to the angle of depression? These two horizontal lines would continue forever and never touch, which makes them a set of parallel lines. So if I were to draw over the horizontal lines, if I use these two lines as parallel lines, and I treat this line of sight as my transversal, the angle of depression and the angle of elevation are really alternate interior angles. So the reason that these angles are always congruent is because of the alternate interior angles theorem. Now, summarizing some of the definitions from the previous slide, it says the angle of elevation is the angle through which the eye moves up from the horizontal line to look at something up above. So an angle of elevation would be something where you have a person and they're looking up at something from a horizontal line. So it's this angle right here. However, the angle of depression is where you have a person up above something and they're looking down at something from the horizontal line. So this is our angle of depression. And using the alternate interior angles, we could say that this angle is the same as that angle of depression. And again, one person's angle of elevation is the other's angle of depression because the angles are congruent. Now, if we look at these examples, for example A, we have our point where we're looking from with our horizontal line and our line of sight. Now, since the individuals are looking up at Mount Rushmore, this would be an example of an angle of elevation. However, for something like B, from point A, if we're looking from the horizontal line at the line of sight, the individual has to look down, making it an angle of depression. Now, if we were to classify the two angles for the diagram shown here, we have angle 1, and looking at angle 1, from the horizontal line, we start at this horizontal line, and we would have to look down to the line of sight. And since angle 1 is looking down, this makes angle 1 an angle of depression. Versus if we look at something like number 2, from the horizontal line, the individual is looking up at the line of sight. So angle 2 is an angle of elevation. Now the following diagram asks us to classify each of the angles in this situation. So if I were to list, I have angle of elevation, or they are being classified as an angle of depression. So looking at the diagram, for angle 1, we're starting at the horizontal line and looking down. So that makes angle 1 an example of an angle of depression. For number 2, we would start at the horizontal line and look up, making angle 2 an angle of elevation. For number 3, we start at the horizontal line and look down, making angle 3 an angle of depression. And for number 4, we start at the horizontal line and go up the line of sight, making number 4 an angle of elevation. Now the last question says which angles are congruent in the diagram. So if I were to erase my markings, based on the parallel lines, so I have my 2 parallel horizontal lines and the transversal. Using that and our alternate interior angles, we know that angle 1 and angle 2 would have to be congruent. So angle 1 is congruent to angle 2. Now for the bottom half of the diagram, we have our 2 parallel lines. So I have my parallel horizontal lines and the line of sight transversal, which using our alternate interior angles makes angle 3 and angle 4 congruent to each other. So angle 3 is congruent to angle 4. Now for a problem such as this, where we have to solve for x, we first have to use our alternate interior angles. So based on the fact that this angle is 27, using my alternate interior angles, the angle in the bottom left is also 27 degrees. Now we can proceed like it's any other problem for trig. So we first want to label our sides. So we have our hypotenuse, opposite, and adjacent. Since there's nothing on the adjacent, I can erase that side length. So I'm left with the opposite and hypotenuse. Now using SOHCAHTOA, since I have the opposite and the hypotenuse, I would have to use sine. So I could write that sine of the angle of 27 equals opposite over hypotenuse. So x over 580. Now we just have to solve as we normally would. So you can multiply both sides by 580. So they cancel. So we have 580 times sine of 27 equals x. And if you plug that into your calculator, it would give you 263.31 yards equals x. Now the next problem says a kite is flying at an angle of elevation of 43 degrees. Find the height of the kite. Find the height of the kite if 37 feet of string have been let out. Now the first thing we have to do, because we are not given a picture, is you always need to draw a picture. So if we know that from the diagram, since it's an angle of elevation, we always start with some sort of diagram like this, where the angle of elevation goes in that bottom left. So in this case, the angle of elevation is 43. Now, if we were to continue to draw in based on what is given, it says that find the height of the kite if 37 feet of string have been let out. So using the fact that I know it's a kite, I'm going to draw my kite. Here's my person. And this is the string of the kite. So it makes this side length 37 feet. The question is asking us for the height of the kite, which means that it's asking for this side length over here. Now, using this diagram, I can set up a trig ratio to solve. So if I were to label my sides, I have the hypotenuse, opposite, and adjacent. Since there's nothing on the adjacent, I can erase that. And using our trig ratios, since it's SOHCAHTOA, I'm given a opposite and hypotenuse, so you'd have to use sine. So I could say that sine of 43 equals x over 37. Now, in order to solve, in this case, we would have to multiply both sides by 37. So you have 37 times sine of 43 equals x. And we plug that in your calculator. It gives you a value of 25.23 feet equals x is your final answer. For our next example, it says an observer at the top of the building sees a car on the road below. The angle of depression to the car is 28 degrees. If the car is 50 meters from the building when it's seen, how tall is the building? Now, since it's an angle of depression problem, as given that it's an angle of depression of 28 degrees, we can set up our diagram to look something like this, where we have our triangle with our horizontal dotted line and the angle outside, that is the angle of depression. Now it tells us that this angle of depression is 28, and using alternate interior angles, this angle inside the triangle, or alternate interior angle, is also 28. Now if I continue to draw the scenario here, it says the observer from the top of a building sees a car on a road below. So this is going to be my building over here with my observer on top, and this is our car down below. Now, it says if the car is 50 meters from the building when it is seen, that means that we're talking about when the distance from the base of the building to the car is 50 meters. So it gives us that this length is 50 meters. The question now is asking how tall is the building. So the height of the building is this value of x over here. Now we're setting up and solving like we normally would for any other problem. So if I label my sides, I have the hypotenuse, opposite, and adjacent. Since there's nothing on the hypotenuse, I can erase it. And now using SOHCAHTOA, since you have the opposite and adjacent, you have to use tangent. So you could say that tangent of 28 equals x over 50. Now to solve this problem, you would have to multiply both sides by 50. So it cancels. So it's 50 times tangent of 28 equals x. And you plug that into your calculator, it gives you 26.56 meters equals x. In our last example, it says the world's tallest unsupported flagpole is 280 is a 282-foot tall steel pole in Surrey, British Columbia. The shortest shadow cast by the pole during the year is 137 feet long. To the nearest degree, what is the angle of elevation of the sun when the shortest shadow is cast? Now, using the fact that it is an angle of elevation problem, we know that our diagram is going to look something like this, where we have this is the angle we're using as our reference angle. Now, if I continue to draw based on what's given in the problem, it says that it's an unsupported flagpole is 282 feet tall. So if I draw my flagpole, the height is 282. And then it says that the shadow of this flagpole is 137 feet long. The shadow is going to be that shadow that's cast on the ground from the flagpole. So this is 137 feet. The question is now asking for the angle of elevation. So that is our value of x. So if I were to set up the problem, we would set it up and label like we normally would in terms of that angle x. So I have the hypotenuse, opposite, and adjacent. Since there's nothing on the hypotenuse, you can erase it. And now, using trig, it's SOHCAHTOA. Since you have the opposite and adjacent, you have to use tangent. So you could say that tangent of x equals 282 over 137. Now, in order to solve, because we are solving for an angle, you have to use inverse trig. To undo the trig that we have there. So if I take the inverse trig of function of both sides, so inverse tangent of tangent of x equals inverse tangent of 282 over 137, the inverse and regular trig will cancel. So it becomes x equals inverse tangent of 282 over 137. If you plug that in your calculator, inverse tangent of 282 divided by 137 gives you a value so that x equals 64.09 degrees, which we can then, if we're rounding to the nearest degree, this would become just 64 degrees.